Greetings to you each. Just a very brief look at a section today. Won't take long at all. Notice it's 5.R.1. The R is for review, which means this stuff should be not too challenging. So you should be happy every time you see an R show up in one of our assignments. This is talking about finding the greatest common factor of a set of terms. And what Hawks will do for you is give you, for instance, two terms and say, what is the greatest common factor here? Greatest common factor means the largest number that will divide evenly into both of these numbers. Some of you can look at it and tell what that is. Others of you will have to go through this procedure. This is a foolproof procedure. It's using the old factor tree idea. So you break the number down into its prime factors. And with your calculator handy, you should have no problem in finding out what these prime factors are. So 9, it turns out, is 3 times 3. 55 is 5 times 11. And the greatest common factor, common meaning what they both have. So you look and see what they both have. They don't have anything. There is no factor that shows up in common. When that happens, you simply say the greatest common factor is 1. 1 is the largest number that will divide evenly into both of these. So when no factor shows up in common with your two factorizations, then your answer is greatest common factor is 1. Let's try another one. Throw in a little bit of XY's here. Hey, do the same thing. Factor tree. You think, what multiplies to give 42? Most people think of 6 times 7. 7 is prime. 6 breaks into 3 times 2. And I've got my prime factorization. 42, it turns out to be 2 times 3 times 7. Typically, when you write the factorization, it's from smallest to largest factor. 15 is 3 times 5. So 15xy. The 15 is 3 times 5. And I've got an x and a y, and just write them out as factors. So everything's listed as a factor. You're looking for what these two lists have in common. Hey, not much, but they have something in common, don't they? Is that it? That's it. So the greatest common factor for these two terms is 3. 3 is the largest value that will divide evenly into both of these guys. Let's try one with 3. Let's go, and what you might want to do is use the factor tree to factor your coefficients, but you can probably do this by sight. 5xy. Not surprisingly, factors into 5 times x times y. 10x squared y squared. 10 factors into 2 times 5. X squared is x's, 2x's. Y squared is 2y's. Now some of you can look at this and tell what the greatest common factor is. I'm giving you a foolproof method in case you have any difficulty at all. 15xy squared. That's 3 times 5. Got 1x and 2y's. All right, let's see what the 3 lists of factors have in common. First of all, they've got a 5 in common, don't they? So my greatest common factor includes 5. Let's see what else they got. Hey, they got an x They all have an x. 5 times x. They've all got a y. And notice these two guys have y's, but 2 out of 3 doesn't count here. You've got to have something in common with every single factorization. And once you've used it once, you're finished. So the greatest common factor is 5xy. Like I said, not too difficult. Let's work a couple more, then we'll turn you loose on this one. How about these? All come right off of your Hawks exercises. Maybe we should break these guys down. This is 9 times 10. Neither one of those is prime. 3 times 3. 2 times 5. So 90, it turns out, is 2 times 3 times 3 times 5. 30, most people think of 3 and 10. That's prime, 10 is not, 2 and 5. So I've got 2 times 3 times 5. And it's got an x and 2 y's. 60. 6 times 10. 2 and 3. 2 and 5. 2, 2, 3, 5. And an x and a y. What do they have in common? Well, they got a 2. They each have a 3. They each have a 5. X's, nope. Y's, nope. This one doesn't have any X's or Y's. So my greatest common factor, 2 times 3 times 5. That's 6 times 5. That's 30. All right, good luck to you on finding your greatest common factors.